Good morning to all. Myself, Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, SIRT, the sales group of all. Today, we will discuss the topic that is MQTT communication of the subject IT 703B IoT of SEM 7. So here, what is the MQTT? Message Queuing Telemetry Transport Protocol is a publish subscribe based messaging protocol, which is designed for the constrained device and low bandwidth, high latency, and unreliable networks. The protocol design principles are to minimize network bandwidth and device resource requirement, also attempting to ensure reliability and some degree of assurance of delivery. MQTT works over the TCP/IP protocol, as I discussed earlier. It uses port 81883, which is assigned by the Internet Assigned Number Authority, that is the IANA. For using MQTT over SSL, port 8883 is used. Now, the main concern is that what is the MQTT broker? In the last lecture, we have discussed regarding that, but here there is need that we should discuss regarding this here. So, what is the MQTT broker? MQTT broker is the heart of each MQTT arrangement. It provides connecting link between applications or physical devices and enterprise systems. Brokers are in change of subscription, determined sessions, missed messages, and the general security, including authentication and authorization. So here are some brokers, and they are the features of the brokers according to limitations. Along with the limitations, that is the broker, Mosquito, RSMB, MQTT.js, HiveMQ, and there are the features and the limitations of these brokers. Their features are regarding the authentications, regarding the QoS, regarding the topics, and in the limitations, they are regarding the security, cluster, and main is that the authentication. So here the MQTT standard packet structure, it consists of one control header, packet length, variable length header, and the payload. Payload means when the message travels, how much load it contains. That is the control header, packet length, variable length header, and the payload. This is inside the MQTT standard packet structure. The control header and the packet length, that is the control header, that is the 1 byte, and the packet length, that is the 1 to 4 byte, that is the fixed header, that is always present, this both. Variable length header, not always present, and size depends on message type. And the payload, that is not always dependent, this contains the data being sent. So this was regarding the MQTT standard packet structure. Now this is the MQTT architecture. As we have discussed earlier, in the MQTT, one is the publisher, broker, and subscriber. So here, the MQTT broker is here, and the MQTT client that is the publisher, and subscriber, the publisher where the data originates, and the subscriber which demands the data. When the client sends the data to the MQTT broker, the data is being kept in the according to the topics. And when subscriber demands the data, that data has been sent according to demand, according to the topics. And as we discussed earlier, the MQTT, that is over the TCP/IP connection, that is the transfer control protocol. In the MQTT architecture, it is divided into two components. As we discussed earlier in the last session also, the publisher and the subscriber, the client and the broker. And the client is here, the publisher and the subscriber. Publisher will publish the data from where the data will come, and subscriber will gain the data. So here the client could be a publisher or subscriber, and it always establishes the network connection to the server group. It can do the following things: publish message for the interested user, subscribe in interested subject for receiving messages, unsubscribe to extract from the subscribed subjects, and detach from the broker. And the broker, that is the broker, control the distribution of information and mainly responsible for receiving all messages from publisher, filtering them, decide who is interested in it, and then sending the messages to all subscribed clients. This is the responsibility of the broker. And it can do the following things: it accepts client request, receive published message by user, processes different requests like subscribe and unsubscribe from user. After receiving messages from the publisher, send it to the interested users. This was regarding the client. Client may be both, that is publisher and subscriber, and the broker. Now the MQTT message communication, that how message communicated using the MQTT. For a connection to establish, both client and broker should have the TCP/IP stack. First thing, the connection with MQTT Connect is initiated by a broker after receiving a command message from the client and will answer the connect. The connection with MQTT Connect is initiated by broker after receiving a command message from the client and will answer with the connect. If a spam message requested and or takes too much time, the connection will be closed. This is for the security reason. Now this is the one scenario where the MQTT Connect message, that is the connect. In the connect, there is the client ID, clean session, username, password, last will topic, last will QoS, last will message, last will retain, and keep alive. These are the some parameters in the connect. The client ID is a unique identifier which is used for connecting to broker by a client. Now we are discussing that is the parameters inside the connect. When we are connecting, that is the MQTT Connect message. The client ID is a unique identifier which is used for connecting to broker by client. The broker uses it to uniquely identify the client and its state. The clean session helps broker in establishing the connection in persistent or non-persistent mode. This is the use of the clean session. In persistent mode, all subscription and messages will be gathered by the broker. Authorization and authentication of a client are managed by username and password. Will message is used in the verification of the MQTT connection message. It helps the notification of the other clients when a client disconnects. Keep alive helps in identifying the status of both broker and client. After a time interval, a ping request is sent by the client and broker responds back with a ping response. The broker responds back with a connect message, CONNACK. This contains session present flag and connection acknowledged flag. The session present flag helps in identifying if the client has a persistent session or not from earlier connections. The other flag is known as the connect acknowledged flag or return code, which indicates whether the connection is successful or not. This was regarding the parameters, that is the MQTT Connect message. Now, the MQTT Connect message, that is the connect, inside this connect, that is the session present, that is the true, and the return code, that is 0. Now, if the session present, that is true, that is okay. And return code, what about the return code? Return code 0 means connection is accepted. 1 means connection is refused because of the unacceptable version. 2, connection is refused because of the identifier rejected. 3, connection is refused because of unavailability of user. 4, connection is refused because of the wrong username or password. 5, connection is refused because of the no authorization. And this is the working of the MQTT, that how the connection is established. Here, I want to get the connect to you. That is the connect. Client request to the broker. From the broker, okay, request accepted. Returns, that is the connect message. I want to get data from these items, that is from the client and the broker, that is subscribe item to subscribe. Here, okay, I will send you when they will be available if the data is not available. That is the back. And here, when the data comes at that time, that data is published to the client. Here, thank you again, the acknowledgement that comes here. This is the working of the MQTT. Now, MQTT format in the MQTT is the case system, naming sensors and actuators. Actuators should follow a categorized and consistent order. For instance, if light, O2, and air sensors are in the basement of an office, the correct way of naming would be, the naming is so important because the meaningful naming will give the convenience to the developer. Suppose here, this my office basement sensor light. Okay, so here inside the sensor, the light sensor, that is where is the light sensor? Light sensor is in the basement in my office. And oxygen sensor, that is the in the basement of my office. Why? So in condition above, wildcards can be used. Now, this is a one scenario of an office LAN being controlled using the MQTT, demonstrating about terms is shown below. That is the MQTT client, that is the device that is published, message on off, that is the topic, home office LAN, this is the subscribe, and the message, that is the on and off, this is the MQTT. This is the one more architecture, that is the high level architecture. MQTT architecture, how it works. Publish a topic, that is the publisher, this is topic, this is the broker. Broker store, forward, filter, and prioritize and QoS. These were the responsibility of the broker, and it will send the data according to topic to the subscribers. So this is the one scenario of the MQTT architecture. Now, what are the drawbacks of the MQTT? MQTT is the most popular communication protocol for IoT, since IoT assets are constrained devices. But it has some limitations which need to be addressed. These are described. Message expiry. Right now, in MQTT, there is no message expiry. That is the main drawback. So, in the event that you put a message in a broker, then forget to gather or nobody ever comes to pick up it. It remains there forever. As a result, the broker is overloaded with the messages and degrades the overall performance. Before discussing further, myself, Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, SIRT, the SAGE group. So here we were discussing regarding the MQTT drawbacks. First, that is that there is no expiry. There is a message expiry. There is in MQTT, there is no message expiry. That should be concerned, because if there is no message expiry and there's nobody that will pick the message, then broker will overload and it will degrade the performance. Second is security. MQTT protocols provides the username and password for authentication, and various broker implementation add different mechanism on top of that. So security in MQTT depends on the use case and selection of broker. Mostly brokers provide security based on TLS, but TLS affects the performance significantly, especially CPU usage during the handshake. So security is the main concern in the MQTT. Ordering. The key challenge for the reliable data transmission organization in the IT environment are the ordering message, resending message, which lost during the transmission. MQTT provides the guaranteed delivery of message, but maintain ordering of message in MQTT is a challenging task, that in which order the message will run. Priority. MQTT does not support any features called the priority of messages. That is the main important concern. If any message that is important, but there is no mechanism that we will set the priority of that message, that this message will go fast, this message will go early than other messages. If any system has more important data, then it must be immediately available to all the subscribers. But for example, the data which is gathered from the fire alarm system is more important than temperature and pressure sensor. So it must be available first to all the receivers. That should be there. So for that, priority of messages are required when sending data out. So here the priority needs. So these are the concerns that MQTT doesn't support the priority. That should be there. So we discuss the major drawbacks, that is the message expiry, security, ordering, and priority. This was all about this MQTT communication. Myself, Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, SIRT, the SAGE Group, Bhopal. Welcomes you. Thanks for watching the video. Thank you.